Welcome, fellow travelers of the night, to a serene exploration of the sleeping brain. Tonight, we delve into the fascinating world of computational neuroscience to uncover how our brains replay memories during sleep, a process crucial for both learning and forgetting. As you prepare to drift off, allow this gentle journey through neural pathways and rhythmic oscillations to soothe your mind and deepen your understanding of the nightly miracle that is sleep. Imagine your brain as a vast, intricate garden. Throughout the day, you plant seeds of experience, new information, skills learned, faces met. But merely planting these seeds isn't enough. They need nurturing, sorting, and sometimes pruning. This is where sleep comes in, transforming your brain into a diligent gardener, working tirelessly while you rest. At the heart of this process lies a phenomenon known as memory replay. During sleep, particularly in slow-wave sleep, your brain reactivates neural patterns that were active during your waking hours. It's as if your brain is replaying the day's highlights, not as a perfect movie, but as a series of fragmented echoes. These echoes aren't random. They're carefully orchestrated to strengthen important memories and discard the less relevant ones. The hippocampus, a seahorse-shaped structure nestled deep within your brain, plays a pivotal role in this replay process. Think of the hippocampus as the initial recording studio for your experiences. It rapidly encodes new information, creating temporary memory traces. However, the hippocampus has limited storage capacity. To ensure long-term retention, these memories need to be transferred to the cortex, the brain's outer layer, for more permanent storage. Memory replay facilitates this transfer. During sleep, the hippocampus talks to the cortex, replaying the day's events in a condensed and accelerated form. This replay strengthens the connections between neurons in the cortex, solidifying the memory. It's like etching a design onto a metal plate. The more you repeat the process, the deeper and more permanent the etching becomes. But why replay memories at all? Why not just store them directly in the cortex? The answer lies in the efficiency of learning. The hippocampus is a fast learner, capable of quickly encoding new information. However, it's also prone to interference. By replaying memories during sleep, the brain can consolidate them in a more stable and organized manner, reducing the risk of forgetting. Consider a student learning a new language. During the day, they attend classes, practice vocabulary, and attempt to construct sentences. These experiences create initial memory traces in the hippocampus. During sleep, the brain replays these language learning episodes, strengthening the connections between the neurons involved in language processing. This replay facilitates the transfer of knowledge from the hippocampus to the cortex, allowing the student to recall and use the new language more fluently. However, memory replay isn't just about strengthening memories. It's also about pruning them. Not all experiences are created equal. Some are crucial for survival and adaptation, while others are trivial and irrelevant. The brain needs a mechanism to distinguish between these two types of memories and selectively strengthen the important ones while discarding the rest. This is where synaptic pruning comes in. During sleep, the brain weakens or eliminates connections between neurons that are rarely used. This process, known as synaptic pruning, is essential for optimizing brain function. It's like weeding a garden, removing the unwanted plants to allow the desirable ones to flourish. Imagine a musician learning a complex piece of music. Initially, they may make many mistakes, activating a wide range of neural pathways. However, with practice and sleep, the brain refines these pathways, strengthening the connections associated with correct notes and rhythms, while weakening those associated with errors. This synaptic pruning allows the musician to perform the piece with greater accuracy and efficiency. The balance between memory consolidation and synaptic pruning is crucial for optimal learning. If the brain only strengthened memories without pruning the irrelevant ones, it would quickly become overloaded with information. Conversely, if the brain only pruned memories without consolidating the important ones, it would struggle to retain new knowledge. Sleep provides the ideal environment for this delicate balancing act. During slow-wave sleep, the brain's activity slows down, creating a state of tranquility that allows for efficient memory replay and synaptic pruning. It's like a quiet workshop where the brain can carefully refine its neural circuits. But how does the brain know which memories to strengthen and which to prune? The answer lies in a complex interplay of factors, including the emotional significance of the experience, its frequency of occurrence, and its relevance to future goals. Memories associated with strong emotions, such as fear or joy, are more likely to be replayed and consolidated. Similarly, memories that are frequently accessed during waking hours are more likely to be retained. Consider a hiker who encounters a bear on a trail. The emotional intensity of this experience will likely lead to strong memory consolidation during sleep. The hiker will vividly remember the bear's appearance, its behavior, and the details of the encounter. This memory will serve as a warning, helping the hiker to avoid similar encounters in the future. In addition to emotional significance and frequency, the brain also considers the relevance of memories to future goals. Memories that are deemed important for achieving future objectives are more likely to be strengthened. This allows the brain to prioritize information that is most likely to be useful in the long run. Imagine a student preparing for an exam. During sleep, the brain will prioritize replaying and consolidating information related to the exam topics. This will help the student to recall the information more easily during the exam, improving their performance. The process of memory replay and synaptic pruning isn't just confined to specific events or facts. It also extends to skills and habits. When you learn a new skill, such as riding a bicycle or playing a musical instrument, your brain undergoes a series of changes that allow you to perform the skill more efficiently. Sleep plays a crucial role in consolidating these changes. During sleep, the brain replays the neural patterns associated with the new skill, strengthening the connections between the neurons involved. This replay allows you to perform the skill more smoothly and automatically. It's like practicing in your sleep, honing your abilities without conscious effort. Consider a tennis player learning a new serve. During the day, they practice the serve repeatedly, refining their technique. During sleep, the brain replays the neural patterns associated with the serve, strengthening the connections between the neurons involved in muscle coordination and timing. This replay allows the player to execute the serve more powerfully and accurately. Furthermore, sleep also helps to consolidate habits. Habits are behaviors that become automatic through repetition. They are often performed without conscious thought, freeing up cognitive resources for other tasks. Sleep plays a crucial role in solidifying these habits, making them more resistant to change. During sleep, the brain replays the neural patterns associated with the habit, strengthening the connections between the neurons involved. This replay makes the habit more ingrained, making it easier to perform automatically. It's like reinforcing a well-worn path, making it easier to follow in the future. Imagine someone trying to quit smoking. During the day, they may resist the urge to smoke, but the habit remains strong. During sleep, the brain replays the neural patterns associated with smoking, strengthening the connections between the neurons involved in craving and addiction. This replay makes it more difficult for the person to break the habit. However, sleep can also be used to break bad habits. By consciously practicing alternative behaviors during the day and reinforcing them during sleep, it's possible to weaken the neural pathways associated with the bad habit and strengthen those associated with the new desired behavior. In addition to memory replay and synaptic pruning, sleep also plays a crucial role in emotional regulation. During sleep, the brain processes and integrates emotional experiences, helping us to cope with stress and anxiety. It's like a nightly therapy session where the brain works through emotional challenges and restores emotional balance. During REM sleep, the brain's emotional centers, such as the amygdala, become highly active. This activity allows the brain to process emotional memories in a safe and controlled environment. It's like rehearsing a difficult conversation in your mind, preparing you to handle similar situations in the future. Consider someone who has experienced a traumatic event. During REM sleep, the brain may replay aspects of the trauma, allowing the person to process the emotions associated with it. This processing can help to reduce the intensity of the emotional memories and prevent them from becoming overwhelming. Furthermore, sleep also helps to regulate the stress hormone cortisol. Cortisol levels typically peak in the morning, helping us to wake up and get going. However, chronic stress can lead to elevated cortisol levels throughout the day, disrupting sleep and contributing to anxiety and depression. Sleep helps to lower cortisol levels, promoting relaxation and reducing stress. It's like a nightly reset button, allowing the body to recover from the stresses of the day. By ensuring adequate sleep, we can help to maintain healthy cortisol levels and promote emotional well-being. As we conclude our exploration of the sleeping brain, let us reflect on the profound importance of sleep for learning, memory, and emotional well-being. Sleep is not merely a period of inactivity. It is a time of intense neural activity where the brain diligently works to consolidate memories, prune irrelevant connections, and regulate emotions. By understanding the science of sleep, we can take steps to optimize our sleep habits and reap the benefits of a well-rested brain. Prioritize sleep, create a relaxing bedtime routine, and cultivate a sleep-friendly environment. Your brain will thank you for it. As you drift off to sleep, imagine your brain as a diligent gardener, tending to the seeds of your experiences. Allow the rhythmic oscillations of your brain waves to soothe your mind and deepen your understanding of the nightly miracle that is sleep. Sweet dreams, and may your sleep be filled with learning, healing, and rejuvenation. Good night. Now let's delve a little deeper into the fascinating mechanisms behind how the brain decides what to keep and what to discard during these nightly replays. A key player in this process is synaptic plasticity, the brain's ability to strengthen or weaken connections between neurons over time in response to increases or decreases in their activity. Think of it as the brain's way of sculpting itself based on your experiences. During wakefulness, new connections are formed and existing ones are strengthened as we learn and experience new things. However, not all of these connections are created equal. Some are crucial for encoding important information, while others are merely fleeting associations. During sleep, the brain meticulously evaluates these connections. The memories that are repeatedly replayed and consolidated become more resistant to forgetting, as the synaptic connections associated with them are strengthened. This strengthening process often involves the transfer of memories from the hippocampus, a temporary storage site, to the neocortex, a more permanent storage location. This transfer allows the hippocampus to be freed up for encoding new memories the next day. But what about the memories that are deemed less important? These connections are weakened or pruned away entirely, a process known as synaptic downscaling. This downscaling is essential for maintaining the brain's overall efficiency and preventing it from becoming overwhelmed with irrelevant information. Imagine trying to navigate a city with every single street, alleyway, and building etched into your memory. It would be incredibly difficult to find your way around. Similarly, the brain needs to selectively forget in order to prioritize the information that is most relevant and useful. This process of synaptic downscaling is thought to be driven by a global reduction in synaptic strength during sleep. This reduction allows the brain to selectively weaken the connections that are not being actively replayed and consolidated. It's like a gentle weeding of the garden, removing the unwanted plants to allow the more important ones to thrive. This process is particularly important during childhood and adolescence, when the brain is undergoing rapid development and learning. Synaptic downscaling helps to refine neural circuits and optimize brain function. Furthermore, the specific types of brain waves that occur during sleep play a crucial role in memory consolidation and forgetting. Slow wave sleep, in particular, is characterized by slow, rhythmic oscillations that are thought to coordinate the replay of memories between the hippocampus and the neocortex. These slow waves provide a temporal framework for the brain to synchronize its activity and strengthen the appropriate connections. REM sleep, on the other hand, is associated with more rapid and irregular brain activity, which may be involved in the emotional processing of memories and the integration of new information with existing knowledge. The interplay between these different sleep stages is essential for the brain to effectively learn and forget. So, as you prepare to sleep, remember that your brain is not simply shutting down. It is actively working to consolidate your memories, prune irrelevant connections, and prepare you for the day ahead. By prioritizing sleep and creating a sleep-friendly environment, you are giving your brain the opportunity to perform these essential functions optimally. Allow yourself to drift into the comforting embrace of sleep, knowing that your brain is diligently working behind the scenes to support your learning, memory, and emotional well-being. Let the gentle rhythm of your breath guide you into a state of deep relaxation, and let your mind wander through the landscapes of your dreams. Good night, and may your journey into sleep be filled with peace, tranquility, and the promise of a refreshed and rejuvenated mind. And as you slumber, consider the fascinating dance of neurochemicals playing out within your brain. Neurotransmitters like acetylcholine, which are elevated during wakefulness and REM sleep, promote synaptic plasticity, the very foundation of learning and memory. Conversely, neurotransmitters like norepinephrine, which are lowered during slow-wave sleep, allow for the weakening of synaptic connections, facilitating the forgetting process. These chemical messengers orchestrate a complex symphony, carefully tuning the brain's activity to optimize memory consolidation and synaptic downscaling. Think of them as the conductors of your brain's nightly performance, ensuring that the right notes are played at the right time. Beyond the neurochemical level, the physical structure of your brain also undergoes subtle but significant changes during sleep. Dendritic spines, the tiny protrusions on neurons that receive signals from other neurons, can grow or shrink depending on the activity patterns that occur during sleep. This dynamic remodeling of synaptic connections allows the brain to refine its circuits and adapt to new experiences. It's as if your brain is a sculptor, constantly shaping and reshaping its neural landscape to create a more efficient and resilient network. The memories you cherish become deeply etched into this landscape, while the less important ones gradually fade away, like footprints washed away by the tide. But what happens when this intricate process of learning and forgetting goes awry? Sleep deprivation, for example, can disrupt the delicate balance of neurochemicals and brain waves that are essential for memory consolidation. This can lead to impaired cognitive function, difficulty concentrating, and an increased risk of accidents. Chronic sleep deprivation can even contribute to long-term memory problems and an increased risk of neurodegenerative diseases. Similarly, sleep disorders like insomnia or sleep apnea can interfere with the brain's ability to effectively replay and consolidate memories, leading to daytime fatigue and cognitive deficits. Prioritizing sleep is not just about feeling rested. It's about safeguarding the health and integrity of your brain. Moreover, the content of your dreams, those often bizarre and surreal experiences that occur during REM sleep, may also play a role in memory processing. While the exact function of dreaming is still a subject of debate among neuroscientists, some theories suggest that dreams may serve as a kind of mental rehearsal, allowing the brain to simulate real-life situations and practice coping strategies. Dreams may also help to integrate new information with existing knowledge, creating new connections and insights. So, even though your dreams may seem random and nonsensical, they may actually be contributing to your brain's ongoing efforts to learn and adapt. Embrace the strange and wonderful world of your dreams, and let them guide you on a journey of self-discovery and cognitive exploration. Therefore, embrace the power of sleep, not just as a period of rest, but as a vital opportunity for your brain to learn, forget, and prepare for the challenges and opportunities that lie ahead. Nourish your mind with positive experiences, engage in stimulating activities, and cultivate a sense of curiosity and wonder. And most importantly, prioritize sleep, creating a sanctuary of peace and tranquility where your brain can work its magic. As you drift off to sleep tonight, know that you're not alone. Your brain is your faithful companion, diligently working behind the scenes to support your learning, memory, and overall well-being. Surrender to the gentle embrace of sleep and allow your mind to wander through the landscapes of your dreams. Sweet dreams, and may your journey into sleep be filled with peace, tranquility, and the promise of a refreshed and rejuvenated mind, ready to embrace the dawn. And as you consider the wonders of sleep, remember the profound impact that external factors can have on this nightly symphony of learning and forgetting. The environment you create for sleep, the darkness, the temperature, the absence of noise, all contribute to the quality and depth of your slumber. Think of your bedroom as a sanctuary, a carefully constructed space dedicated to the art of restorative sleep. Blackout curtains can help to block out intrusive light, signaling to your brain that it's time to produce melatonin, the hormone of darkness. A cool room temperature, typically between 60 and 67 degrees Fahrenheit, can promote deeper sleep by lowering your core body temperature and minimizing noise, whether through the use of earplugs or a white noise machine, can help to prevent disruptions that can fragment your sleep and interfere with memory consolidation. Beyond the immediate environment, consider the impact of your daily habits on your sleep. The choices you make throughout the day, what you eat, when you exercise, how you manage stress, can all influence the quality of your sleep at night. Avoid consuming caffeine or alcohol close to bedtime, as these substances can disrupt your sleep architecture and prevent you from reaching the deeper, more restorative stages of sleep. Regular exercise can promote better sleep, but avoid intense workouts in the hours leading up to bedtime, as this can have a stimulating effect. And practice stress reduction techniques, such as meditation or deep breathing exercises, to calm your mind and prepare your body for sleep. Think also about the power of consistency. Establishing a regular sleep schedule, going to bed and waking up at the same time each day, even on weekends, can help to regulate your body's natural sleep-wake cycle, known as your circadian rhythm. This internal clock governs a wide range of physiological processes, including hormone production, body temperature, and alertness. By aligning your sleep schedule with your circadian rhythm, you can optimize your sleep quality and enhance your brain's ability to learn and forget effectively. And finally, remember that sleep is not a luxury, but a fundamental biological necessity. Just as you need food, water, and air to survive, you also need sleep to thrive. It is during these quiet hours, as you slumber peacefully, that your brain works tirelessly to consolidate memories, clear out toxins, and prepare you for the challenges and opportunities that await you in the waking world. So, embrace the power of sleep, prioritize your sleep hygiene, and cultivate a deep appreciation for the transformative potential of this nightly ritual. Allow yourself to drift off into a world of dreams, knowing that your brain is working diligently behind the scenes to support your health, well-being, and cognitive function. Good night, and may your sleep be deep, restorative, and filled with the promise of a brighter, more alert tomorrow, as you lie in bed, ready to surrender to sleep. Consider the symphony of activity unfolding within your brain. It's not merely shutting down, it's actively processing, refining, and reorganizing the vast amount of information you've accumulated throughout the day. Think of it as a diligent librarian, meticulously reshelving books, discarding outdated materials, and creating new connections between seemingly disparate ideas. This nightly curation is essential for maintaining cognitive clarity and ensuring that you wake up feeling refreshed and ready to learn anew. Focusing on your breath can be a powerful tool as you transition into sleep. Deep, slow breaths activate the parasympathetic nervous system, often referred to as the rest and digest system. This counteracts the effects of stress and anxiety, slowing your heart rate, lowering your blood pressure, and creating a sense of calm that is conducive to sleep. Imagine each inhale drawing in peace and tranquility, and each exhale releasing tension and worry. This simple practice can help to quiet the mental chatter that often keeps us awake at night, allowing your brain to more effectively engage in its nightly replay and consolidation processes. Beyond the physiological benefits, sleep also provides a crucial period for emotional regulation. During sleep, the brain processes emotional experiences, helping to detach the emotional charge from specific memories. This allows you to wake up with a more balanced perspective, less reactive to triggers that might have previously caused distress. It's as if your brain is gently smoothing out the rough edges of your emotional landscape, creating a more even and resilient terrain. So, as you drift off to sleep, trust that your brain is working to heal and restore not only your cognitive function, but also your emotional well-being. And as you sleep, remember that the process of forgetting is just as important as remembering. The brain doesn't retain every single detail of every experience. Instead, it selectively prunes away irrelevant or outdated information to make room for new learning. This process, known as synaptic pruning, is essential for maintaining cognitive efficiency and preventing information overload. Think of it as a gardener carefully tending to a garden, removing weeds and dead leaves to allow the healthy plants to thrive. By forgetting what is no longer needed, your brain creates space for new growth and allows you to focus on what truly matters. So, tonight, as you close your eyes and prepare to sleep, Embrace the quiet power of your brain's nightly replay. Know that as you rest, your brain is working tirelessly to consolidate memories, clear out toxins, regulate emotions, and prepare you for a brighter, more alert tomorrow. Sweet dreams, and may your sleep be filled with the promise of learning, growth, and renewal. And consider this: the very architecture of your dreams can be viewed as a reflection of this nightly cognitive dance. The often bizarre and illogical narratives that unfold during REM sleep might seem random, but they could represent the brain's attempt to explore novel connections between disparate memories, forging new pathways and insights. Think of it as your brain engaging in a form of creative problem solving, unconstrained by the rules and limitations of waking thought. These nocturnal explorations can lead to unexpected breakthroughs and a deeper understanding of yourself and the world around you. So, even in the seemingly chaotic realm of dreams, there is a purpose, a method to the madness, a hidden order driving the brain's nightly symphony. Furthermore, the quality of your sleep directly impacts the effectiveness of these crucial brain functions. Factors like sleep duration, sleep depth, and sleep consistency all play a role in determining how well your brain can consolidate memories, regulate emotions, and prune unnecessary information. Chronic sleep deprivation, for example, could disrupt these processes, leading to cognitive impairments, mood disturbances, and an increased risk of neurological disorders. Therefore, prioritizing sleep is not just about feeling rested. It's about actively supporting the health and well-being of your brain. It's an investment in your cognitive future, a commitment to maintaining optimal brain function throughout your life. And while we often focus on the individual brain, it's important to remember that sleep also plays a role in social cognition. During sleep, the brain processes social cues and emotional signals, helping us to better understand and respond to the needs of others. This is particularly important for developing empathy and maintaining healthy relationships. When we are sleep deprived, our ability to accurately interpret social signals can be impaired, leading to misunderstandings and conflicts. So, sleep is not just a personal need. It's a social imperative, a foundation for building strong and supportive communities. As you continue to relax, imagine your brain as a complex and intricate network, constantly adapting and evolving in response to your experiences. Each new piece of information, each new skill learned, each new relationship formed, leaves its mark on this network, shaping its structure and function. And during sleep, your brain works tirelessly to integrate these new experiences into your existing knowledge base, strengthening some connections and weakening others. This dynamic process of learning and forgetting is what allows us to grow and adapt, to become more resilient and resourceful individuals. So, let go of the day's worries and anxieties, and trust in the power of your brain to heal, restore, and renew. Allow yourself to drift off into a peaceful and restorative sleep, knowing that your brain is working diligently behind the scenes to optimize your cognitive function and emotional well-being. Embrace the quiet darkness, and let the gentle rhythm of your breath guide you into a state of deep relaxation. Good night, and may your sleep be filled with the promise of a brighter, more alert, and more fulfilling tomorrow. May you awaken refreshed, rejuvenated, and ready to embrace the day with clarity, focus, and a renewed sense of purpose. And as you drift deeper into slumber, consider the fascinating role of dreams in this nightly cognitive process. While the exact function of dreams remains a subject of ongoing research, many neuroscientists believe they serve as a kind of mental playground, a space where the brain can experiment with different scenarios, consolidate memories, and even generate creative solutions to waking life problems. Dreams may allow us to process emotions, confront fears, and explore possibilities in a safe and simulated environment. They are a testament to the brain's incredible capacity for imagination and self-reflection, a nightly reminder that our inner world is just as rich and complex as the external one. Think of your dreams as a personalized movie crafted by your own subconscious mind. The characters, the plot lines, the settings, all are drawn from your memories, your experiences, and your deepest desires. And while the narrative may seem nonsensical or even bizarre at times, there's often a hidden logic, a deeper meaning waiting to be uncovered. By paying attention to your dreams, you can gain valuable insights into your own thoughts, feelings, and motivations. You can learn to recognize patterns, identify recurring themes, and even use your dreams as a source of inspiration and guidance. As you continue to breathe deeply and relax, remember that sleep is not just a passive state of rest. It is an active and dynamic process, a crucial period of repair, restoration, and rejuvenation. During sleep, your body releases hormones that promote tissue growth and repair, your immune system strengthens its defenses, and your energy reserves are replenished. Sleep is the foundation upon which our physical and mental health is built, the bedrock of our overall well-being. Without sufficient sleep, we become more vulnerable to illness, more prone to stress, and less capable of functioning at our best. So, prioritize sleep. Make it a non-negotiable part of your daily routine. Create a sleep-friendly environment, free from distractions and conducive to relaxation. Establish a regular sleep schedule, going to bed and waking up at the same time each day, even on weekends. Practice good sleep hygiene, avoiding caffeine and alcohol before bed, and engaging in relaxing activities in the evening. And remember, sleep is not a luxury. It is a necessity, an investment in your health, your happiness, and your future. It's the silent architect of a sharper mind and a more resilient spirit. Now, let your thoughts gently fade away like whispers in the wind. Release any tension you may be holding in your body, allowing your muscles to soften and your breath to deepen. Feel yourself sinking deeper and deeper into the mattress, surrendering to the embrace of sleep. You are safe, you are secure, and you are loved. Your brain is working tirelessly on your behalf, sorting through the day's events, consolidating your memories, and preparing you for a brighter tomorrow. Trust in this process, surrender to the moment, and allow yourself to drift off into a peaceful and restorative sleep. Sweet dreams. As you drift further into slumber, consider the incredible efficiency of your brain's nightly replay. It's not just replaying events in a linear fashion like rewinding a tape. It's more like a skilled editor, sifting through the raw footage of your day, selecting the most relevant scenes, and then weaving them together into a more coherent and impactful narrative. This process isn't always perfect, of course. Sometimes, memories can become distorted or fragmented, like a film reel that's been damaged over time. But even these imperfections can be valuable, offering new perspectives and insights into your experiences. Think of the hippocampus, the brain's memory hub, as the stage where these nightly replays unfold. During wakefulness, the hippocampus diligently records every detail of your experiences, creating a detailed map of your surroundings and the events that occur within them. But it's during sleep, particularly during slow-wave sleep, that the hippocampus truly shines. It's then that the hippocampus begins to reactivate these memory traces, sending signals to the neocortex, the brain's outer layer responsible for long-term storage. This reactivation is often synchronized with the activity of the neocortex, allowing the two regions to communicate and strengthen the connections between them. This communication is crucial for memory consolidation, the process by which short-term memories are transformed into long-term memories. Imagine the hippocampus as a temporary holding area, where memories are stored briefly before being transferred to the neocortex for permanent safekeeping. During sleep, the hippocampus acts as a guide, leading the neocortex through the pathways of your memories, reinforcing the neural connections that represent them. The more often these pathways are activated, the stronger they become, making it easier to recall those memories in the future. But the brain's nightly replay isn't just about strengthening memories. It's also about forgetting. Just as a gardener prunes away dead or dying branches to promote healthy growth, the brain selectively prunes away unnecessary or irrelevant information to make room for new learning. This process, known as synaptic pruning, is essential for maintaining the efficiency and flexibility of the brain. It allows us to focus on the most important information and avoid being overwhelmed by irrelevant details. The mechanisms underlying forgetting are still not fully understood, but it's believed that sleep plays a crucial role. During sleep, the brain releases certain chemicals that weaken the connections between neurons, making it more difficult for those neurons to communicate with each other. This process is particularly important for pruning away memories that are no longer relevant or useful. So, while it may seem counterintuitive, forgetting is actually an essential part of learning. It allows us to clear away the clutter and focus on the information that truly matters. As you continue to relax, consider the incredible adaptability of your brain. It's constantly learning and adapting, even while you sleep. Every night, your brain is working tirelessly to consolidate your memories, prune away unnecessary information, and prepare you for the challenges of the day ahead. It's a remarkable feat of engineering, a testament to the power and resilience of the human brain. So, trust in this process, surrender to the moment, and allow yourself to drift off into a deep and restful sleep, knowing that your brain is taking care of you even as you dream. You are safe, you are secure, and you are loved. Let go of any worries or anxieties and allow yourself to be carried away on the gentle waves of sleep. Sweet dreams, and may your sleep be filled with peace and restoration. And that's why understanding this delicate dance between memory consolidation and synaptic pruning is so important. It's not just about remembering more, it's about remembering better. It's about optimizing our cognitive resources to make the most of our learning potential. Think of it like this. Your brain is a vast library, and sleep is the librarian diligently organizing the shelves. Some books are carefully placed in the important section, readily accessible for future reference. Others, deemed less relevant, are moved to the archive or even discarded to make room for new acquisitions. This continuous process of organization and refinement ensures that the library remains a valuable resource, capable of providing the information you need when you need it. Now, let's delve a little deeper into the fascinating world of brainwaves and their role in this nightly symphony of learning and forgetting. You see, sleep isn't just a passive state of rest. It's an active process characterized by distinct patterns of brainwave activity. These brainwaves, measured by electroencephalography, EEG, reflect the synchronized electrical activity of millions of neurons firing together. Different stages of sleep are associated with different brainwave frequencies, each playing a unique role in memory consolidation and synaptic pruning. For example, slow-wave sleep, also known as deep sleep, is characterized by slow, high-amplitude brain waves that are crucial for transferring memories from the hippocampus, the brain's short-term memory storage, to the neocortex, the long-term storage area. During this stage, the brain replays recent experiences, strengthening the connections between neurons involved in those memories. Then there's REM sleep, or rapid eye movement sleep, which is characterized by brainwave activity that resembles wakefulness. This is the stage of sleep when most vivid dreams occur, and it's also thought to be important for consolidating emotional memories and integrating new information with existing knowledge. During REM sleep, the brain engages in a process called synaptic scaling, which involves downscaling the overall strength of synaptic connections. This helps to prevent the brain from becoming overwhelmed by information and allows it to maintain a stable level of excitability. It's like turning down the volume on all the connections, ensuring that the important signals still stand out clearly. This process is also thought to be crucial for forgetting unnecessary or irrelevant information. So, you see, each stage of sleep contributes in its own unique way to the complex process of learning and forgetting. It's a delicate balance, a finely tuned orchestration of brainwave activity and neurochemical processes that work together to optimize our cognitive function. And the more we understand about this process, the better equipped we are to harness the power of sleep to improve our learning, memory, and overall well-being. As you continue to relax, consider the intricate workings of your brain, the millions of neurons firing in synchrony, the delicate balance between consolidation and pruning. It's a truly remarkable feat of nature, a testament to the power and adaptability of the human brain. Allow yourself to be amazed by its complexity, to be humbled by its resilience, and to trust in its ability to take care of you even as you sleep. Breathe deeply, release any tension in your body, and allow yourself to drift off into a peaceful and restorative sleep, knowing that your brain is working tirelessly to consolidate your memories, prune away unnecessary information, and prepare you for the challenges of the day ahead. You are safe, you are secure, and you are loved. Let go of any remaining worries or anxieties, and allow yourself to be carried away on the gentle waves of sleep. Sweet dreams, and may your sleep be filled with peace, restoration, and the quiet hum of a brain diligently at work. And now, as you settle even deeper into relaxation, let's delve a little further into the fascinating realm of specific brain regions and their roles during sleep. Think about the hippocampus, that seahorse-shaped structure nestled deep within your brain. During the day, it's a whirlwind of activity, constantly encoding new experiences and forming connections between them. As you drift off to sleep, the hippocampus begins to replay these experiences, essentially reactivating the neural pathways that were formed during waking hours. This replay isn't a perfect replica, though. It's more like a condensed and reorganized version, highlighting the most salient details and strengthening the connections that are most important. This process is particularly crucial for consolidating declarative memories, those facts and events that you can consciously recall. Imagine learning a new language, for instance. During the day, you might struggle to remember new vocabulary and grammar rules. But as you sleep, the hippocampus works tirelessly to consolidate these new pieces of information, making them more readily accessible when you wake up. It's like the brain is practicing in its sleep, reinforcing the neural pathways that are essential for language acquisition. But the hippocampus isn't the only player involved in this nightly replay. The neocortex, the outer layer of your brain responsible for higher level cognitive functions, also plays a vital role. While the hippocampus initially encodes memories, the neocortex is responsible for long-term storage. During sleep, the hippocampus gradually transfers information to the neocortex, allowing it to become more stable and resistant to interference. This transfer process is thought to occur during slow-wave sleep, when brainwave activity is slow and synchronized, creating an ideal environment for communication between these two brain regions. Think of it like moving files from your computer's temporary storage to its hard drive. The hippocampus is like the temporary storage, quickly encoding new information but not designed for long-term retention. The neocortex is like the hard drive, capable of storing vast amounts of information for years to come. During sleep, the brain diligently transfers files from the hippocampus to the neocortex, ensuring that important memories are safely stored and readily accessible. Furthermore, consider the role of specific neurotransmitters, those chemical messengers that transmit signals between neurons. During sleep, The levels of certain neurotransmitters, such as acetylcholine, decrease, while the levels of others, such as GABA, increase. This shift in neurotransmitter balance promotes synaptic plasticity, the ability of synapses to strengthen or weaken over time. This plasticity is essential for both learning and forgetting. When synapses are strengthened, memories are consolidated and become more resistant to forgetting. When synapses are weakened, unnecessary or irrelevant information is pruned away, freeing up space for new learning. This intricate interplay between brain regions, brainwave activity, and neurotransmitter balance is what allows the brain to optimize its cognitive function during sleep. It's a dynamic and adaptive process, constantly adjusting to the demands of your waking life. And as you continue to breathe deeply and relax, know that your brain is working tirelessly to support your learning, memory, and overall well-being. Allow yourself to surrender to the peace and quiet of the night, trusting that your brain is taking care of you, even as you sleep. Let go of any remaining thoughts or worries, and allow yourself to be carried away on the gentle currents of sleep. May your dreams be peaceful, your sleep be restorative, and may you wake up feeling refreshed, rejuvenated, and ready to embrace the day ahead. Sleepwell.so. While you drift off, picture this nightly symphony playing out in your head. It's not just a passive process. It's an active reorganization, a constant refinement of your cognitive landscape. Think about the sheer efficiency of it all. While your conscious mind rests, your brain is hard at work, sifting through the day's experiences, deciding what to keep and what to discard. It's like a diligent librarian, carefully cataloging and archiving the most important books, while gently removing the ones that are no longer needed. But what happens when this process goes awry? What if the brain fails to properly consolidate memories during sleep? This is where we start to see the connection between sleep disturbances and cognitive decline. Studies have shown that individuals who suffer from chronic sleep deprivation or sleep disorders, such as insomnia or sleep apnea, often experience difficulties with memory and learning. This is because the brain isn't getting the opportunity to properly replay and consolidate memories during sleep. The files aren't being transferred efficiently, and important information can be lost or corrupted. Furthermore, research suggests that sleep may also play a role in forgetting traumatic or emotionally charged memories. While it may seem counterintuitive, forgetting can be just as important as remembering. By selectively pruning away negative or distressing memories, the brain can protect itself from being overwhelmed by emotional pain. This process, known as adaptive forgetting, is thought to involve specific brain regions, such as the amygdala, which is responsible for processing emotions. During sleep, the amygdala may work in conjunction with other brain regions to downregulate the emotional intensity of certain memories, making them less likely to trigger negative feelings in the future. Consider, too, the different stages of sleep and their unique contributions to memory processing. During slow-wave sleep, the deepest stage of sleep, the brain exhibits slow, rhythmic brain waves that are thought to be particularly important for consolidating declarative memories, those memories that can be consciously recalled, such as facts and events. REM sleep, on the other hand, is characterized by rapid eye movements and brainwave activity that resembles wakefulness. REM sleep is believed to play a crucial role in consolidating procedural memories, those memories that involve skills and habits, such as riding a bike or playing a musical instrument. So, each stage of sleep contributes in its own way to the overall process of learning and forgetting. And as you continue to relax, perhaps visualizing those slow brain waves gently washing over your mind, remember that you can actively support your brain's nightly replay by prioritizing good sleep hygiene. This includes establishing a regular sleep schedule, creating a relaxing bedtime routine, and avoiding caffeine and alcohol before bed. By making sleep a priority, you're giving your brain the opportunity to perform its essential work, ensuring that you wake up feeling refreshed, alert, and ready to learn and remember new things. So, breathe deeply, let go of any tension in your body, and allow yourself to drift off into a peaceful and restorative sleep. Trust that your brain is working diligently behind the scenes, taking care of your memories and preparing you for the day ahead. Sweet dreams. Now, let's delve a little deeper into the fascinating mechanisms by which the brain orchestrates this nightly learning and forgetting symphony. One crucial player in this process is a phenomenon called synaptic plasticity. Synapses, those tiny gaps between neurons, are the points of communication within the brain. Synaptic plasticity refers to the brain's ability to strengthen or weaken these connections over time based on experience. During wakefulness, as we encounter new information and have new experiences, certain synaptic connections become strengthened, making it easier for those neurons to communicate with each other in the future. This strengthening is the basis of learning and memory formation. However, not all experiences are created equal, and not all memories are worth holding onto indefinitely. That's where the forgetting part comes in. During sleep, the brain selectively weakens or prunes certain synaptic connections, particularly those that are deemed irrelevant or unimportant. This process, known as synaptic downscaling, is thought to be essential for maintaining the overall efficiency of the brain and preventing it from being overwhelmed by unnecessary information. Think of it like a gardener carefully pruning a rose bush, removing dead or weak branches to allow the healthy ones to flourish. In a similar way, the brain prunes away weak or unimportant synaptic connections to make room for new learning and to strengthen the connections that really matter. Furthermore, the brain doesn't just passively replay memories during sleep. It actively reorganizes and integrates them into existing knowledge networks. This process involves the hippocampus, a brain region that acts as a temporary storage site for new memories. During sleep, the hippocampus communicates with the cortex, the outer layer of the brain responsible for higher-level cognitive functions, to transfer and consolidate memories. This transfer is not a simple copying process. Rather, it involves the integration of new information with existing knowledge, allowing us to make sense of the world around us and to form more robust and meaningful memories. It's like taking individual puzzle pieces and fitting them together to create a larger, more complete picture. The memories are not just stored, but actively woven into the fabric of our existing understanding. Consider also the role of various neurotransmitters in this intricate dance of learning and forgetting. Neurotransmitters are chemical messengers that transmit signals between neurons. Some neurotransmitters, such as acetylcholine, are known to promote wakefulness and alertness, while others, such as GABA, have a calming and inhibitory effect. During sleep, the levels of certain neurotransmitters fluctuate, creating an environment that is conducive to memory consolidation and synaptic downscaling. For example, the decrease in acetylcholine levels during sleep may allow the brain to disengage from external stimuli and focus on internal processes, such as memory replay. And while we've touched upon the importance of sleep hygiene, it's worth reiterating just how crucial it is for optimal brain function. Chronic sleep deprivation can disrupt the brain's natural learning and forgetting processes, leading to impaired memory, reduced cognitive performance, and an increased risk of various health problems. So, making sleep a priority is not just about feeling rested. It's about supporting the fundamental processes that allow us to learn, remember, and adapt to the world around us. As you continue to relax and let go of any lingering thoughts or worries, remember that your brain is a remarkable organ, constantly working to optimize your learning and memory processes. Trust in its ability to take care of you, even as you sleep. Allow yourself to drift deeper into a state of peaceful relaxation, knowing that your brain is busy consolidating memories, pruning away unnecessary information, and preparing you for a bright and productive tomorrow. Let the gentle rhythm of your breath lull you into a deep and restorative sleep. Good night. Now let's delve a little deeper into the specific brain regions involved in this nightly replay. The hippocampus, often considered the brain's memory center, plays a starring role. During wakefulness, the hippocampus is actively encoding new experiences, creating detailed maps of our surroundings and linking them to specific events. But during sleep, particularly during slow-wave sleep, the hippocampus reactivates these neural patterns, essentially replaying the day's events at a faster pace. This replay is not an exact replica, but rather a compressed and abstracted version, highlighting the most salient and relevant information. This hippocampal replay is not a solo act. It's a collaborative effort involving the neocortex, the brain's outer layer responsible for higher-level cognitive functions. The neocortex is where long-term memories are ultimately stored, but relies on the hippocampus to initially process and organize new information. During sleep, the hippocampus communicates with the neocortex, transferring these replayed memories and gradually integrating them into existing cortical networks. This process is known as systems consolidation, and it's essential for transforming fragile, short-term memories into stable, long-term knowledge. Think of it like this. The hippocampus is the temporary workshop where new memories are initially crafted, while the neocortex is the permanent storage facility where these memories are eventually archived. Sleep is the critical period when the contents of the workshop are carefully transported to the archive ensuring that they are properly organized and preserved for future use. Without sufficient sleep, this transfer process is disrupted, leaving memories fragmented and vulnerable to being lost or forgotten. But the story doesn't end there. While sleep is crucial for solidifying important memories, it's also essential for pruning away irrelevant or redundant information. This process, known as synaptic downscaling, helps to prevent the brain from becoming overloaded with unnecessary details. During wakefulness, our synapses, the connections between neurons, are constantly strengthening and multiplying as we learn new things. However, if these connections were to continue strengthening indefinitely, the brain would eventually become saturated, leading to cognitive overload and impaired learning. Sleep provides an opportunity for the brain to selectively weaken or eliminate the least important synapses, freeing up resources for the most relevant and meaningful connections. This downscaling process is thought to be driven by a global reduction in synaptic activity during slow-wave sleep, allowing the brain to identify and prune away the weakest connections. It's like a gardener carefully tending to a garden, removing the weeds and dead leaves to allow the healthy plants to thrive. So, as you drift off to sleep tonight, remember that your brain is not simply shutting down. It's actively engaged in a complex and vital process of learning and forgetting. It's consolidating the day's experiences, integrating them into your existing knowledge, and pruning away unnecessary information. Trust in its ability to take care of you, to optimize your memories, and to prepare you for a bright and productive tomorrow. Let the gentle waves of sleep wash over you, carrying away any lingering stress or anxiety. Allow your mind to quiet and your body to relax, knowing that you are giving your brain the rest and rejuvenation it needs to function at its best. Breathe deeply, release any tension, and allow yourself to surrender to the peaceful embrace of sleep. Sweet dreams. And while we've touched on the mechanisms of synaptic downscaling during sleep, the precise molecular signals and neural circuits orchestrating this elegant process are still being actively investigated. One fascinating area of research focuses on the role of glial cells, particularly microglia, in synaptic pruning. These cells, often considered the brain's immune sentinels, have been shown to engulf and eliminate synapses during sleep, contributing to the refinement of neural circuits. Imagine them as tiny cleanup crews, diligently removing the debris of neural activity, ensuring that only the strongest and most relevant connections remain. Furthermore, the balance between synaptic potentiation, the strengthening of connections, and synaptic depression, the weakening of connections, is delicately regulated during sleep. This balance is crucial for maintaining the stability of neural circuits and preventing runaway excitation or inhibition. Think of it as a carefully calibrated seesaw, constantly adjusting to maintain equilibrium. Disruptions to this balance, such as those seen in sleep disorders or neurodevelopmental conditions, can lead to cognitive impairments and altered brain function. The impact of sleep on memory extends beyond individual synapses and circuits, influencing the organization and function of large-scale brain networks. During sleep, different brain regions communicate with each other in a coordinated fashion, facilitating the transfer and integration of information. For example, the hippocampus, a brain region critical for forming new memories, interacts with the neocortex, the seat of higher-level cognitive functions, during slow-wave sleep. This interaction is thought to be essential for transferring memories from the temporary storage in the hippocampus to the more permanent storage in the neocortex. It's like moving files from your computer's RAM to its hard drive. Moreover, sleep plays a crucial role in emotional processing and regulation. During sleep, the amygdala, the brain's emotional center, processes emotional memories, helping us to regulate our emotional responses and adapt to stressful situations. Sleep deprivation, on the other hand, can impair emotional processing, leading to increased irritability, anxiety, and difficulty regulating emotions. So, getting a good night's sleep is not just important for cognitive function, it's also essential for emotional well-being. Consider the intricate dance between different sleep stages, the slow, deep waves of non-REM sleep and the rapid eye movements of REM sleep. Each stage plays a distinct role in memory processing. Non-REM sleep, particularly slow-wave sleep, is crucial for consolidating declarative memories, the memories of facts and events. REM sleep, on the other hand, is thought to be important for consolidating procedural memories, the memories of skills and habits, as well as emotional memories. The cyclical alternation between these sleep stages ensures that different types of memories are processed and integrated in an optimal manner. And as research continues to unravel the mysteries of sleep and memory, one thing is clear. Sleep is not a passive state of inactivity, but rather an active and dynamic process that is essential for learning, memory, and overall brain health. So, prioritize sleep, create a conducive sleep environment, and allow your brain to work its magic as you slumber. Let the science of sleep guide you to a restful and rejuvenating night, knowing that you are investing in your cognitive and emotional well-being. Allow yourself to drift into the realm of dreams, where your brain continues its nightly replay, shaping your memories and preparing you for the adventures that await you in the waking world. Sleep well and wake up refreshed with a mind ready to learn, remember, and thrive. As we gently transition into the depths of sleep, it's fascinating to consider the role of specific brainwave patterns in this nightly orchestration of memory. Think of these brainwaves, delta, theta, alpha, and sigma, as the conductors of silent symphony, each contributing to a unique aspect of memory consolidation. Delta waves, prominent during deep sleep, are associated with the transfer of memories from the hippocampus, our brain's short-term storage center, to the neocortex, the long-term storage hub. Theta waves, prevalent during REM sleep and also present in earlier sleep stages, are thought to facilitate the integration of new information with existing knowledge, weaving new experiences into the tapestry of our long-term memories. Alpha waves, present as we begin to relax and drift off to sleep, signify a state of calm alertness, a gateway to deeper slumber and the memory processes that follow. And finally, sigma waves, characteristic of sleep spindles during non-REM sleep, are believed to play a crucial role in protecting memories from interference, ensuring their stability and longevity. Beyond brain waves, neurochemicals also play a pivotal role in this nightly memory ballet. Consider acetylcholine, a neurotransmitter vital for learning and memory during wakefulness. Its levels decrease during slow-wave sleep, allowing for the strengthening of connections between neurons that were activated during the day. This process, known as synaptic consolidation, solidifies memories by making the neural pathways associated with them more efficient and resilient. On the other hand, during REM sleep, acetylcholine levels surge, promoting synaptic plasticity and the integration of new and existing memories. This delicate balance of neurochemicals during different sleep stages highlights the intricate orchestration of memory processes occurring as we sleep. Furthermore, the glymphatic system, the brain's unique waste clearance system, becomes highly active during sleep. Imagine it as a sophisticated plumbing system, flushing out metabolic waste products that accumulate in the brain throughout the day. This cleansing process is crucial for maintaining optimal brain function and preventing the buildup of toxins that can impair cognitive processes, including memory consolidation. By clearing the brain's environment, the glymphatic system creates a more conducive environment for the formation and storage of memories. It's like cleaning a dusty hard drive to improve its performance, a vital function for maintaining cognitive clarity. And let's not forget the influence of dreams on this nightly replay. While the exact function of dreams remains a topic of ongoing research, many scientists believe that they play a role in emotional processing and memory consolidation. Dreams may provide a safe space for the brain to simulate and process emotional experiences, helping us to regulate our emotions and adapt to stressful situations. Moreover, dreams may also facilitate the integration of new information with existing knowledge, allowing us to make sense of our experiences and form new insights. The bizarre and often illogical nature of dreams may reflect the brain's attempt to explore different possibilities and connections, fostering creativity and problem-solving abilities. So, the next time you find yourself lost in a vivid dream, remember that your brain is actively working to process information, consolidate memories, and prepare you for the challenges and opportunities of the waking world. Now, how does the brain decide what to keep and what to discard during these nightly replays? It's not simply a matter of remembering everything we experience during the day. Instead, the brain prioritizes information based on its relevance, emotional significance, and association with existing knowledge. This selective consolidation process ensures that we retain the most important and useful information while filtering out the noise. Synaptic tagging and capture is one mechanism thought to play a crucial role here. Imagine each synapse, the connection between neurons, having a little tag. When a significant experience occurs, the synapses involved are tagged. During sleep, when consolidation processes are in full swing, these tags attract the necessary resources, proteins, and other molecules to strengthen those specific synaptic connections, effectively solidifying the associated memory. But what about forgetting? It might seem counterintuitive, but forgetting is just as important as remembering. Our brains are constantly bombarded with information, and if we tried to retain everything, we would quickly become overwhelmed. Forgetting allows us to clear out irrelevant or outdated information, freeing up space for new learning and preventing cognitive overload. Active forgetting, a process sometimes referred to as synaptic pruning, involves weakening or eliminating synaptic connections that are no longer needed. This process is particularly prominent during childhood and adolescence, a period of rapid brain development and learning. However, it continues throughout adulthood, ensuring that our brains remain efficient and adaptable. Think of it like weeding a garden. By removing the unwanted plants, you create space for the healthy ones to thrive. The precise mechanisms underlying active forgetting are still being investigated, but several factors are thought to be involved. One key player is the protein known as muscle-related receptor tyrosine kinase, or MuSK for short. MuSK has been shown to promote the weakening of synapses, effectively marking them for elimination. Other factors, such as sleep deprivation and stress, can also disrupt the delicate balance between memory consolidation and forgetting, leading to impaired cognitive function. In fact, chronic sleep deprivation has been linked to a variety of cognitive problems, including memory deficits, difficulty concentrating, and impaired decision-making. This highlights the crucial role of sleep in maintaining optimal brain function and ensuring that our memories are properly processed and stored. So, as you drift off to sleep tonight, remember that your brain is hard at work, replaying your day, consolidating important memories, and pruning away the unnecessary ones. It's a complex and fascinating process, orchestrated by a symphony of neurochemicals, brain waves, and cellular mechanisms. By understanding the science of sleep and memory, we can gain a deeper appreciation for the remarkable capabilities of the human brain and take steps to optimize our sleep habits to enhance learning, memory, and overall cognitive well-being. Sweet dreams, and may your nightly replay be filled with valuable insights and lasting memories. Now, let's delve a little deeper into the fascinating world of brain waves and their role in this nightly replay. You might have heard of different types of brain waves, such as alpha, beta, theta, and delta waves. Each of these brain waves is associated with different states of consciousness and plays a specific role in sleep and memory consolidation. For instance, slow wave sleep, which is characterized by the presence of delta waves, is thought to be particularly important for consolidating declarative memories, the memories of facts and events. During slow wave sleep, the hippocampus, which acts as a temporary storage site for memories, communicates with the neocortex, the brain's long-term storage center. This communication involves the replay of neural activity patterns that were present during wakefulness, effectively transferring the memories from the hippocampus to the neocortex for long-term storage. Think of it like backing up your computer files. The hippocampus is like your computer's RAM, providing quick access to recent information. The neocortex is like your external hard drive, offering a more permanent storage solution. During sleep, Your brain is essentially backing up the important files from the hippocampus to the neocortex, ensuring that they are safely stored for future retrieval. And this process isn't just a passive transfer of information. It's an active process of reorganization and integration. As memories are replayed, they're also integrated with existing knowledge, allowing us to make new connections and gain deeper insights. This is why sleep is so important for learning and problem solving. When you sleep on a problem, you're not just passively resting. Your brain is actively working to find solutions by integrating new information with existing knowledge. Beyond the hippocampus and neocortex, other brain regions also play crucial roles in memory replay during sleep. The amygdala, for example, which is involved in processing emotions, can influence which memories are prioritized for consolidation. Memories associated with strong emotions are often more likely to be replayed and strengthened during sleep, which may explain why we tend to remember emotional events more vividly than neutral ones. The cerebellum, which is involved in motor control and coordination, also plays a role in consolidating motor skills during sleep. If you're learning a new skill, such as playing a musical instrument or riding a bike, sleep is essential for solidifying those skills and improving your performance. Furthermore, the neurochemicals in our brain are critical for the nightly memory replay. Neurotransmitters like acetylcholine, dopamine, and norepinephrine fluctuate throughout the sleep cycle and influence the strength and stability of synaptic connections. For example, acetylcholine levels are typically high during wakefulness and REM sleep, which is associated with dreaming and memory consolidation. Dopamine, which is involved in reward and motivation, can also influence memory consolidation by strengthening the synaptic connections associated with rewarding experiences. Norepinephrine, which is involved in alertness and arousal, can modulate the emotional salience of memories, making them more or less likely to be replayed during sleep. Understanding the interplay between brain waves, brain regions, and neurochemicals is key to unlocking the secrets of sleep and memory. By optimizing our sleep habits and creating an environment conducive to restful sleep, we can enhance our brain's ability to consolidate memories, prune away unnecessary information, and ultimately improve our cognitive function and overall well-being. So, tonight, as you prepare for sleep, consider creating a relaxing bedtime routine, minimizing exposure to screens before bed, and ensuring that your sleep environment is dark, quiet, and cool. These simple steps can go a long way in promoting restful sleep and allowing your brain to perform its nightly replay effectively. And remember, a well-rested brain is a brain that is ready to learn, remember, and thrive. Sleep tight, and may your dreams be filled with pleasant memories and insightful revelations. Now, let's delve a little deeper into the fascinating process of how our brains decide what to keep and what to discard during this nightly replay. It's not a random process. There's a sophisticated system in place, a kind of mental librarian meticulously curating our memories. One key aspect of this curation is synaptic pruning, a process where the brain eliminates weaker synaptic connections while strengthening the important ones. Think of it like tidying up a garden. You remove the weeds and support the plants you want to flourish. This pruning is crucial for optimizing brain function, preventing information overload, and ensuring that we retain the most relevant and useful memories. The mechanisms driving synaptic pruning are complex and involve a variety of cellular processes. One important player is microglia, the brain's resident immune cells. Microglia act like tiny vacuum cleaners, engulfing and removing unnecessary synapses and cellular debris. This process is particularly active during sleep, highlighting the critical role of sleep in maintaining a healthy and efficient brain. Furthermore, the strength of a synaptic connection is determined by its activity. Synapses that are frequently used are strengthened, while those that are rarely used are weakened and eventually eliminated. This use it or lose it principle is a fundamental aspect of brain plasticity, allowing our brains to adapt and learn from experience. Another fascinating aspect of memory consolidation during sleep is the role of sharp wave ripples, which are brief bursts of neural activity that originate in the hippocampus and propagate to other brain regions, particularly the cortex. These ripples are thought to be involved in transferring memories from the hippocampus, which acts as a temporary storage site, to the cortex, where they're stored long-term. During sharp wave ripples, the brain replays patterns of neural activity that were present during waking experiences, effectively reactivating and reinforcing those memories. This replay is not an exact replica of the original experience, but rather a compressed and abstracted version, focusing on the most salient features. Interestingly, the content of these replays can be influenced by our experiences and expectations. For example, if you're anticipating an important event, your brain may rehearse it during sleep, preparing you for the challenges ahead. Similarly, if you're struggling with a problem, your brain may continue to work on it unconsciously during sleep, potentially leading to new insights and solutions. This highlights the remarkable capacity of our brains to process information and solve problems even when we're not consciously aware of it. So, when you wake up with a sudden solution to a problem that plagued you the day before, you can thank your sleeping brain for its diligent work behind the scenes. The process of memory replay during sleep isn't just about strengthening existing memories. It's also crucial for integrating new information with existing knowledge. When we learn something new, that information is initially stored in a fragile state, easily disrupted. Sleep-dependent replay allows the brain to connect this new information to relevant memories and experiences already stored in the cortex, creating a more robust and integrated representation. This integration process is vital for building a coherent understanding of the world and for making informed decisions based on past experiences. Think of it like filing a new document not just in a cabinet, but cross-referencing it with related files to build a complete picture. Now, let's delve into the fascinating topic of forgetting during sleep. While sleep is undeniably essential for memory consolidation, it also plays a crucial role in pruning away irrelevant or outdated information. This process, known as synaptic downscaling, is thought to occur primarily during slow-wave sleep, the deepest stage of non-REM sleep. During synaptic downscaling, the overall strength of synaptic connections throughout the brain is reduced, effectively weakening less important memories and freeing up space for new learning. This is not to say that all memories are weakened during sleep. Rather, the brain selectively weakens those connections that are deemed less relevant or useful based on patterns of activity during waking hours. The balance between memory consolidation and forgetting during sleep is a delicate one, and it's crucial for maintaining a healthy and efficient brain. Imagine if we remembered every single detail of every single day. Our brains would quickly become overwhelmed with irrelevant information, making it difficult to focus on what's truly important. Forgetting, therefore, is not a failure of the brain, but rather an essential mechanism for filtering out noise and prioritizing what matters most. It's like decluttering your mental space, getting rid of the things you no longer need, so you can focus on the things that are truly valuable. Furthermore, the specific types of memories that are consolidated or forgotten during sleep can be influenced by various factors, including stress, emotions, and the individual's learning goals. For example, stressful experiences tend to be highly memorable, and sleep may play a role in consolidating these memories, potentially contributing to the development of post-traumatic stress disorder. Conversely, if you're actively trying to forget something, such as a painful memory, your brain may engage in specific strategies during sleep to weaken the associated synaptic connections. The interplay between these factors is complex and not fully understood, but it highlights the remarkable adaptability of the brain in response to our experiences. The brain is not a static repository of information, but a dynamic and ever-changing organ that is constantly adapting to our needs and experiences, even while we sleep. It's a continuous process of learning, forgetting, and refining our understanding of the world. Now, let's delve a bit deeper into the mechanisms that facilitate this nightly replay and subsequent learning and forgetting. One key player is a type of brainwave called sleep spindles. These are bursts of rapid brain activity that occur during stage 2 sleep, a phase often referred to as light sleep, but critically important for memory processing. Think of sleep spindles as brief, intense signals that strengthen the connections between neurons involved in reactivated memories. The more sleep spindles you experience, particularly in brain regions like the hippocampus and cortex, the better you're likely to perform on memory tasks. They essentially act as a catalyst, solidifying the neural pathways associated with the information you've learned during the day. But it's not just about strengthening connections. Sleep also involves the coordinated release of various neurochemicals that modulate synaptic plasticity, the brain's ability to change and adapt. For example, during sleep, levels of norepinephrine, a neurotransmitter associated with alertness and stress, tend to decrease. This allows the brain to enter a more permissive state, where synaptic connections can be more easily modified. Simultaneously, the release of growth factors and other molecules that support neuronal health and survival is enhanced, promoting the long-term consolidation of important memories. It's a carefully orchestrated symphony of chemical signals, all working together to optimize the brain's learning and forgetting processes. Another critical factor is the role of glial cells, often considered the support staff of the brain. While neurons are responsible for transmitting information, glial cells, particularly astrocytes, play a crucial role in regulating synaptic connections. During sleep, astrocytes can actually prune or eliminate synapses that are deemed weak or unnecessary, further contributing to the forgetting process. This process, known as synaptic pruning, is thought to be essential for maintaining the efficiency of neural circuits and preventing the brain from becoming overloaded with irrelevant information. It's like weeding a garden, removing the unwanted plants to allow the healthy ones to thrive. This glial activity is finely tuned, ensuring that only the appropriate connections are weakened, not the crucial ones needed for long-term memory. And what about dreams? While the exact function of dreaming is still debated, some researchers believe that dreams may represent a form of offline memory processing. During REM sleep, the brain exhibits patterns of activity that closely resemble those seen during waking experiences, and it's thought that these patterns may reflect the replay and reorganization of memories. Dreams might be a way for the brain to simulate different scenarios, test out new ideas, and integrate new information with existing knowledge. While the content of dreams may often seem bizarre or nonsensical, the underlying neural processes may be playing a crucial role in learning and adaptation. It's like running a simulation of your day, identifying potential problems and solutions, and fine-tuning your responses for future events. Dreams could be the brain's way of rehearsing life, even while you're asleep.so. We've talked about replay, consolidation, glial cells, and even dreams. But how does the brain decide what to remember and what to forget? That's where the concept of synaptic tagging and capture comes into play. Think of it like this. When a neuron fires during a learning experience, it gets a little tag attached to its synapses, signaling that this particular connection is important. Now, when the brain goes into replay mode during sleep, these tag synapses become targets for consolidation. But the brain also needs resources, proteins, and other molecules to strengthen these connections. These resources are limited, so the brain needs a way to prioritize which tag synapses get the most attention. This is where capture comes in. Stronger tags, perhaps resulting from more significant or emotionally relevant experiences, are more likely to capture these consolidation resources. Weaker tags, on the other hand, might fade away, leading to the eventual weakening and elimination of the corresponding synapses. It's a competitive process where the most important memories get the resources they need to solidify, while less relevant memories are gradually pruned away. This elegant system ensures that the brain isn't just randomly strengthening connections, but rather selectively reinforcing the memories that are most likely to be useful in the future. Beyond the cellular and molecular mechanisms, the brain also utilizes larger-scale network dynamics during sleep to orchestrate learning and forgetting. Specific brain regions, such as the hippocampus, crucial for forming new memories, and the neocortex, responsible for long-term storage, engage in coordinated activity patterns during sleep. The hippocampus, which initially encodes new experiences, repeatedly reactivates these memories during sleep, essentially teaching the neocortex what to remember. This process, known as hippocampal neocortical dialogue, involves the transfer of information from the temporary storage in the hippocampus to the more permanent storage in the neocortex. As memories are repeatedly replayed and transferred, they become more stable and less reliant on the hippocampus. Over time, the neocortex becomes capable of retrieving these memories independently, freeing up the hippocampus to focus on encoding new experiences. The precise timing and coordination of these network interactions are critical for successful memory consolidation. Disruptions to sleep, particularly slow-wave sleep, can impair this hippocampal neocortical dialogue, leading to deficits in memory formation and recall. It's like a carefully choreographed dance between different brain regions, each playing a vital role in the creation and storage of our memories. Furthermore, the emotional context of an experience plays a significant role in determining whether it will be remembered or forgotten. Memories associated with strong emotions, whether positive or negative, tend to be more vividly encoded and more resistant to forgetting. This is because emotional experiences trigger the release of stress hormones, such as cortisol and adrenaline, which can enhance synaptic plasticity and strengthen memory consolidation. The amygdala, a brain region involved in processing emotions, interacts closely with the hippocampus to modulate memory formation. Emotional memories are often prioritized for consolidation during sleep, ensuring that we remember important events that could have implications for our survival or well-being. However, it's also important to note that traumatic experiences can lead to the formation of intrusive and persistent memories. In these cases, the brain may struggle to properly process and integrate the traumatic event, leading to symptoms such as flashbacks and nightmares. Understanding the role of emotion in memory processing is crucial for developing effective treatments for conditions such as post-traumatic stress disorder, PTSD. Ultimately, the brain's nightly replay is a complex and multifaceted process that involves a delicate interplay of cellular, molecular, and network mechanisms. It's a continuous cycle of learning and forgetting, shaping our memories, influencing our behavior, and ultimately defining who we are. By understanding the intricate workings of this process, we can gain valuable insights into the nature of memory, learning, and consciousness. And perhaps we can even learn how to optimize our own sleep to improve our memory and enhance our cognitive abilities. As you drift off to sleep tonight, remember that your brain is hard at work, replaying your day, consolidating your memories, and preparing you for whatever tomorrow may bring. Sweet dreams, and may your memories be vivid and lasting as so. The next time you find yourself tossing and turning, unable to quiet your mind, consider the possibility that your brain is simply working through the day's events, sorting through the important information and discarding what is no longer needed. It's a bit like a diligent librarian constantly organizing and updating the collection, ensuring that everything is in its proper place. This nightly process isn't just about passively storing information. It's an active process of reconstruction and reorganization. Memories aren't simply copied and pasted into long-term storage. They're actively re-encoded, strengthened, and integrated with existing knowledge. This means that each time a memory is reactivated during sleep, it has the potential to be modified and updated, reflecting our current understanding of the world. Think of it as your brain's own personal editing suite, where it can fine-tune the narrative of your life, removing unnecessary details, highlighting key events, and ensuring that the story makes sense. This editing process is crucial for maintaining a coherent sense of self and for adapting to new experiences. Without it, our memories would be fragmented and disorganized, making it difficult to learn from the past and to navigate the future. Furthermore, the brain's nightly replay is not just about individual memories. It's also about the connections between them. As memories are reactivated and consolidated during sleep, the brain is able to identify patterns and relationships between different events. This allows us to form broader concepts and generalizations, which are essential for understanding the world around us. For example, if you consistently experience a particular pattern of events, such as a series of positive interactions with a new colleague, your brain will begin to form a general expectation that this person is trustworthy and reliable. This expectation can then influence your future interactions with this person, shaping your behavior and your perception of the world. And it's fascinating to consider how different stages of sleep contribute to this intricate memory dance. Slow wave sleep, with its deep, restorative waves, seems particularly crucial for transferring memories from the hippocampus to the neocortex, the brain's long-term storage site. REM sleep, on the other hand, with its vivid dreams and rapid eye movements, may play a role in integrating new memories with existing knowledge and in processing emotional experiences. So, as you cycle through these different stages of sleep each night, your brain is orchestrating a complex symphony of neural activity, carefully tuning and refining your memories. It's a truly remarkable feat of biological engineering, happening silently and effortlessly as you slumber. And while we've talked a lot about the consolidation of memories, let's not forget about the importance of forgetting. Forgetting is not simply a failure of memory. It's an active process that is essential for maintaining a healthy cognitive system. Just as a gardener prunes away dead or dying branches to promote new growth, the brain actively prunes away unnecessary or irrelevant memories to make room for new information. This process, known as synaptic pruning, involves the selective elimination of weak or unused connections between neurons. By removing these connections, the brain is able to streamline its neural circuits, making them more efficient and responsive. So, the next time you forget something, don't beat yourself up about it. Remember that forgetting is a natural and necessary part of the learning process. It's your brain's way of clearing out the clutter and focusing on what's truly important. And who knows, maybe those forgotten memories will resurface in a dream, offering you a new perspective or a fresh insight. As you continue to explore the mysteries of your own mind, remember that sleep is not just a period of rest and recovery. It's an active and dynamic process that is essential for learning, memory, and overall cognitive health. Now, close your eyes, take a deep breath, and allow yourself to drift off into the world of dreams, knowing that your brain is hard at work, ensuring that your memories are vivid, long-lasting, and ready for whatever tomorrow may bring. Sleep well. And speaking of dreams, have you ever wondered why some dreams are so vivid and memorable, while others fade away like mist? The intensity and emotional content of our dreams can significantly impact how well we remember them. Dreams that are highly emotional or personally significant are more likely to be encoded into long-term memory. This is because the amygdala, the brain's emotional center, becomes highly active during these dreams, and this heightened activity strengthens the connections between the dream experience and other related memories. Furthermore, the neurochemicals released during sleep, such as acetylcholine, also play a crucial role in dream recall. Acetylcholine levels are particularly high during REM sleep, and this neurotransmitter is known to enhance synaptic plasticity and memory consolidation. So, if you want to improve your dream recall, try focusing on your emotional state before you fall asleep. Engage in activities that promote relaxation and positive emotions, such as meditation or listening to calming music. This can help to prime your brain for more vivid and memorable dreams. Now, let's delve a little deeper into the cellular mechanisms underlying memory replay. At the heart of this process are specialized brain cells called neurons. Neurons communicate with each other through electrical and chemical signals, forming intricate networks that represent our memories and experiences. During wakefulness, these networks are constantly being activated and modified as we interact with the world. But during sleep, these networks undergo a process of reactivation and consolidation, strengthening the connections between neurons and making the memories more stable and resistant to forgetting. One key player in this process is a type of brain wave called a sharp wave ripple. Sharp wave ripples are brief bursts of neural activity that occur primarily in the hippocampus, a brain region critical for memory formation. These ripples are thought to be the neural signature of memory replay, and they play a crucial role in transferring memories from the hippocampus to the cortex, where they can be stored for the long term. During sharp wave ripples, the same patterns of neural activity that were present during the initial learning experience are replayed at a much faster rate. This accelerated replay helps to strengthen the synaptic connections between the relevant neurons, making the memory more durable and accessible. Interestingly, the content of these memory replays is not always an exact replica of the original experience. Sometimes, the brain may replay only fragments of memory, or it may combine different memories together to create new associations and insights. This process of memory recombination is thought to be important for creativity and problem solving, as it allows the brain to explore different possibilities and generate novel solutions. So, even when you're asleep, your brain is actively working to make sense of your experiences and to create new connections and insights. And remember, the process of learning and forgetting is not just about individual memories. It's also about the overall organization and structure of your knowledge. The brain is constantly reorganizing its neural networks to optimize its performance and to adapt to new information. This process of reorganization involves both strengthening and weakening connections between neurons, as well as creating new connections and eliminating old ones. It's a dynamic and ongoing process that shapes who we are and how we perceive the world. So, as you drift off to sleep tonight, know that your brain is working tirelessly to consolidate your memories, to prune away unnecessary information, and to reorganize your knowledge in a way that will benefit you in the days and weeks to come. Allow yourself to relax and surrender to the restorative power of sleep, trusting that your brain is taking care of everything, ensuring that you wake up refreshed, rejuvenated, and ready to tackle whatever challenges lie ahead. Sweet dreams. And when we're talking about this constant neural housekeeping that goes on while we sleep, it's worth diving a little deeper into the mechanisms that govern which memories are strengthened and which are allowed to fade. It's not a random process. There are specific signals and cues that the brain uses to prioritize certain memories over others. One key factor is the emotional salience of the memory. Memories that are associated with strong emotions, whether positive or negative, are more likely to be replayed and consolidated during sleep. This makes intuitive sense, as these emotionally charged experiences are often the ones that are most relevant to our survival and well-being. The brain recognizes their importance and makes sure they are properly encoded and stored. Another important factor is the frequency with which a memory is accessed and used during waking hours. The more you actively recall and use a particular memory, the stronger its neural representation becomes, and the more likely it is to be replayed during sleep. This highlights the importance of active learning and practice. If you want to remember something, don't just passively read about it once. Actively engage with the material, quiz yourself, and try to apply it in different contexts. This will not only strengthen the initial memory trace, but also increase the likelihood that it will be prioritized for consolidation during sleep. Furthermore, the brain also takes into account the context in which a memory was formed. Memories that are associated with a specific place, time, or social setting are often replayed together, allowing the brain to strengthen the connections between these related experiences. This contextual replay helps to create a more coherent and interconnected web of knowledge, allowing you to better understand and navigate the world around you. Think of it as your brain filing away memories not just individually, but also within relevant folders and subfolders, making it easier to retrieve them later when needed. But what about the forgetting part of the equation? Why does the brain bother to prune away memories that it deems unnecessary? Well, the answer is that forgetting is just as important as remembering. If we remembered every single detail of every single experience, our brains would quickly become overloaded with information, making it difficult to focus on what's truly important. Forgetting allows us to filter out irrelevant details, to generalize from past experiences, and to create more efficient and streamlined representations of the world. It's a form of neural sculpting, carefully shaping our memories to optimize our cognitive abilities. Moreover, forgetting can also be a protective mechanism. Traumatic or highly stressful memories can be incredibly painful to recall. By gradually weakening the connections associated with these memories, the brain can help us to cope with difficult experiences and to move forward with our lives. This doesn't mean that the memories are completely erased, but rather that they become less vivid and less emotionally charged, making them easier to manage. The process of forgetting is thought to involve several different mechanisms, including the weakening of synaptic connections between neurons, the removal of unnecessary synapses, and the active suppression of certain memories. One key player in this process is a protein called protein phosphatase 1, or PP1 for short. PP1 acts like a cellular eraser, removing chemical tags that strengthen synaptic connections and allowing them to weaken over time. By carefully regulating the activity of PP1, the brain can selectively prune away memories that are no longer needed. So, you see, sleep is far more than just a period of rest and recuperation. It's a critical time for the brain to consolidate your memories, to reorganize your knowledge, and to prune away unnecessary information. It's a time for learning and forgetting, for strengthening and weakening connections, for creating new insights, and letting go of old baggage. It's a dynamic and ongoing process that shapes who you are and how you perceive the world. As you continue to relax, envision your brain diligently at work, orchestrating this intricate symphony of neural activity. Let go of the day's worries and trust in your brain's remarkable ability to heal, adapt, and learn. Allow yourself to drift deeper into slumber, knowing that you are in good hands and that you will wake up refreshed, rejuvenated, and ready to embrace a new day. Sleep well, and as you rest, consider the fascinating interplay between different sleep stages and their unique contributions to this nightly cognitive overhaul. REM sleep, characterized by rapid eye movements and vivid dreams, is thought to be particularly important for consolidating emotional memories and integrating new information with existing knowledge. During REM sleep, the brain exhibits high levels of activity, almost as if it were reliving past experiences and exploring new possibilities. Non-REM sleep, on the other hand, is characterized by slower brain waves and is thought to be more important for consolidating factual memories and strengthening motor skills. During non-REM sleep, the brain replays patterns of neural activity that occur during wakefulness, reinforcing the connections between neurons that were active during the day. These different sleep stages work together in a coordinated fashion to ensure that memories are properly processed and stored. As you cycle through these stages throughout the night, your brain is constantly evaluating the importance of different memories and deciding which ones to keep and which ones to discard. This process is guided by a complex interplay of chemical signals, electrical activity, and structural changes in the brain. Think of it as your brain sifting through the day's experiences, carefully selecting the most relevant and important information and discarding the rest. It's like a librarian organizing a vast collection of books, carefully categorizing and shelving each one so that it can be easily retrieved later. The brain is constantly working to create a coherent and organized representation of the world, and sleep is the time when it fine-tunes this representation. Furthermore, consider the role of glial cells, the unsung heroes of the brain. While neurons are responsible for transmitting information, glial cells provide crucial support and maintenance. During sleep, glial cells step up their activity, clearing away metabolic waste products that accumulate during wakefulness and providing nutrients to neurons. They also play a role in regulating synaptic connections, helping to strengthen important connections and weaken unnecessary ones. In essence, they are the cleaning crew and construction workers of your brain, ensuring everything is in optimal working order. And it's not just about individual memories. Sleep also helps to consolidate and refine your overall understanding of the world. As you sleep, your brain integrates new information with existing knowledge, creating new connections and insights. This process can lead to breakthroughs in problem solving, enhanced creativity, and a deeper understanding of complex concepts. You might even wake up with a fresh perspective on a problem that had been plaguing you for days. So, embrace this time of rest, knowing that your brain is actively working to improve your cognitive abilities and to shape your understanding of the world. Let go of any anxieties or worries that may be lingering in your mind and allow yourself to drift deeper into slumber. Trust in the remarkable power of your brain to heal, adapt, and learn. As you sleep, you are not just resting. You are actively shaping your mind and preparing yourself for a brighter, more fulfilling future. Sweet dreams. And remember, even seemingly uneventful sleep cycles contribute significantly to your cognitive well-being. Each stage of sleep, from the light dozing of stage 1 to the deep restorative slumber of stage 3 and 4, and the vivid dreaming of REM sleep, plays a unique role in this intricate process. During slow-wave sleep, for instance, the brain synchronizes its activity, generating slow, rhythmic waves that sweep across the cortex. These waves are thought to facilitate the transfer of memories from the hippocampus, a temporary storage site, to the neocortex, where they could be permanently stored and integrated with other knowledge. This nightly migration of memories is a testament to the brain's remarkable ability to reorganize and optimize its information processing. Furthermore, the dreams you experience during REM sleep are not merely random images and sensations. They may also play a crucial role in memory consolidation and emotional regulation. While the exact function of dreaming is still a topic of debate among neuroscientists, there is growing evidence that dreams help us to process and make sense of our experiences, to resolve emotional conflicts, and to explore different possibilities and scenarios. It's like the brain is running simulations, experimenting with different outcomes and strengthening the connections between related concepts. So, even if your dreams seem bizarre or nonsensical, they may be serving a valuable purpose in shaping your cognitive landscape. Think of your brain as a vast and intricate network of interconnected pathways, constantly adapting and evolving in response to your experiences. Sleep is the time when this network undergoes a period of intense remodeling and reorganization, pruning away unnecessary connections and strengthening the ones that are most important. This process is guided by the principles of synaptic plasticity, the brain's ability to change the strength of connections between neurons in response to experience. The more you use a particular connection, the stronger it becomes. The less you use it, the weaker it becomes. It's like a gardener carefully tending to a garden, pruning away the weeds and nurturing the flowers. And it's not just about retaining information. Sleep also helps us to forget things that are no longer relevant or useful. This process, known as synaptic downscaling, is essential for preventing the brain from becoming overloaded with information and for maintaining its efficiency. By weakening or eliminating unnecessary connections, the brain can make room for new information and focus its resources on the most important tasks. It's like decluttering your home, getting rid of things you no longer need so that you can create a more organized and functional living space. So, as you prepare to drift off to sleep, remember that your brain is about to embark on a remarkable journey of learning, forgetting, and reorganization. Embrace the stillness and quiet of the night, knowing that your mind is actively working to improve your cognitive abilities and to shape your understanding of the world. Let go of any worries or concerns that may be weighing on your mind, and allow yourself to be carried away by the gentle rhythm of your breath. Trust in the innate wisdom of your brain to guide you through this process and to emerge refreshed and rejuvenated in the morning. Close your eyes, breathe deeply, and allow yourself to sink deeper into the embrace of sleep. Let the magic of the night work its wonders and awaken to a brighter, more insightful tomorrow. Sleep well, and as you sleep, remember that the brain isn't just passively consolidating memories. It's actively replaying them. Imagine a musician practicing a complex piece of music. During the day, they might stumble and make mistakes, but as they sleep, their brain replays the musical sequence, solidifying the correct finger placements and transitions, turning conscious effort into effortless skill. This replay isn't a perfect replica. It's more like a compressed and abstracted version of the day's experiences. The brain extracts the essential patterns and relationships, strengthening the connections between neurons that fire together during these replays. These patterns are replayed in a sped-up manner, almost like a highlights reel of your day, allowing the brain to process a vast amount of information in a relatively short period. This replay process is intimately linked to sleep stages, particularly slow-wave sleep, the deepest and most restorative phase. During slow-wave sleep, the brain exhibits large, slow oscillations that synchronize neuronal activity across wide areas. These oscillations create a fertile ground for memory consolidation, allowing the brain to efficiently transfer information from the hippocampus, a temporary storage site for memories, to the neocortex, the brain's long-term storage vault. The hippocampus acts like a guide, replaying the day's events and directing the neocortex on which connections to strengthen and which to weaken. Interestingly, the emotions associated with our memories also play a crucial role in this process. Memories with strong emotional content tend to be replayed more frequently and vividly during sleep, leading to stronger and more lasting consolidation. This explains why emotionally charged experiences, both positive and negative, often stick with us more vividly than mundane events. The amygdala, the brain's emotional center, interacts closely with the hippocampus during sleep, modulating the replay process based on the emotional significance of the memories. So, even as you sleep, your emotions are subtly shaping the landscape of your memories. Furthermore, this nightly symphony of learning and forgetting isn't just about individual memories. It's also about integrating new information with existing knowledge, creating a richer and more nuanced understanding of the world. As the brain replays and consolidates memories, it also identifies patterns and connections between different experiences, forming new associations and insights. This process is akin to building a vast and intricate web of knowledge, where each new experience adds another thread to the tapestry. Sleep, therefore, is not just a period of rest, but a crucial period of intellectual synthesis, allowing us to make sense of our experiences and to develop a more coherent and comprehensive worldview. So, as you drift further into slumber, envision your brain as a tireless architect, constantly refining and reshaping the architecture of your mind. Embrace the power of sleep to unlock your cognitive potential and to cultivate a deeper understanding of yourself and the world around you. Let the gentle waves of sleep wash over you, carrying away the day's stresses and anxieties, and allowing your brain to work its magic. Surrender to the stillness, knowing that you are in the midst of a profound and transformative process. Breathe deeply, relax completely, and allow yourself to be transported to the realm of dreams, where the boundaries of reality blur and the possibilities are endless. Sweet dreams, and may your sleep be filled with the whispers of wisdom and the promise of a brighter tomorrow. And as you journey deeper into the night, consider the fascinating role of sleep spindles in this intricate process. These brief bursts of brain activity, occurring predominantly during stage 2 sleep, are thought to play a crucial role in memory consolidation. Imagine them as tiny spotlights, momentarily illuminating specific neural pathways, strengthening the connections between neurons involved in the memories being replayed. The more sleep spindles you experience, particularly in regions like the hippocampus and cortex, the more effectively your brain is likely to consolidate and integrate new information. Think of them as the brain's way of saying, "Pay attention, this is important." Furthermore, the process of forgetting, while often seen as a negative, is just as crucial as learning for maintaining a healthy and efficient brain. It's not simply about erasing unwanted memories. It's about prioritizing and streamlining the information that's most relevant and useful. During sleep, your brain actively prunes away weaker or less important connections, preventing your neural circuits from becoming overloaded with irrelevant details. This process, known as synaptic pruning, ensures that the most important memories are retained while the less significant ones fade into the background. It's like decluttering your mental space, creating room for new experiences and insights. Without this nightly process of forgetting, our brains would become overwhelmed, making it difficult to retrieve the information we truly need. Consider also the impact of different sleep stages on memory processing. Slow wave sleep, the deepest stage of non-REM sleep, is particularly important for consolidating declarative memories, those facts and events that you can consciously recall. REM sleep, on the other hand, seems to play a more critical role in consolidating procedural memories, the skills and habits that you perform automatically, like riding a bike or playing a musical instrument. As you cycle through these different sleep stages throughout the night, your brain is meticulously sorting, organizing, and solidifying different types of memories, ensuring that you wake up feeling refreshed and ready to tackle the day ahead. And it's not just about what happens during sleep, but also what happens before sleep that can influence memory consolidation. Engaging in active learning strategies, such as spaced repetition or elaborative interrogation, can significantly enhance the replay and consolidation process during sleep. By actively engaging with the material you want to learn, you prime your brain for more effective memory processing during the night. Think of it as giving your brain a head start, making it easier to solidify those new connections and integrate them into your existing knowledge base. So, the next time you're trying to learn something new, consider incorporating these active learning techniques to maximize the benefits of sleep. Finally, remember that sleep is a deeply personal and individual experience. The amount and quality of sleep you need can vary depending on a variety of factors, including age, genetics, and lifestyle. Experiment with different sleep schedules and routines to find what works best for you. Create a relaxing bedtime ritual. Avoid screens before bed, and ensure that your sleep environment is dark, quiet, and cool. By prioritizing sleep and creating a conducive environment, you can optimize your brain's ability to learn, forget, and synthesize information, unlocking your full cognitive potential. Allow these thoughts to gently fade as you drift off, knowing that your brain is working tirelessly to refine and enhance your mind. Let go of any lingering worries or concerns, and simply surrender to the peace and tranquility of sleep. Good night.